Greetings, TME community. Today I will present the HiluxNest, which is the project for the Smart Home for Small Birds contest. As always, we start with a briefly research, taking into account our small feather friends. We have checked that they withstand a temperature range from 18 to 24 Celsius degrees and humidity from 40 to 70% relative humidity. In base of this data, we take a look about some insulation materials, which for instance are acrylic with a thermal conductivity of 0.19 watt meter Kelvin, or cork with a thermal conductivity of 0.04 watt meter per Kelvin, and finally the MDF, which is more available commercially in the market, and it has also a nice thermal conductivity. We are looking for a material that it's insulated enough and it can be productive for our small nest. For that case, we search for the best insulator, the most available, and also cheap if it can be. For that case, we have observed that MDF is one of the best options. Well, in order to be quicker, we start to look for which kind of birds can we make a birdhouse. So we focus on the small birds because of the size, the lighting, weight, and customizable this bird box can be, allow us to make different modifications, and also cheap. So in this manner, we take a look of some options from the market and we pick one. We didn't design it because we were dedicated more in the electronics. Okay, the creativity plan that we have done, it's first check how insulated it is, and then electro customize it for keep it warm. Then for the insulation testing that we have done over this house, without any modifications on the house, we measure the outdoor temperature and humidity, and at the same time the indoor temperature and humidity, in order to get a delta T, which is the difference between the outdoor temperature and the indoor temperature, to see how much it preserves temperature, or if it isolates by any chance. In order to make this, we measure then temperature and humidity outdoors, indoors, but we also need to save the measurements along hours, such that allow us to later compute this delta T. And obviously we need a continuously power, otherwise we cannot continue the measuring. In order to do this, we came up with this circuit, which is a normal data logger, but it includes a power cell, solar power cell that is recharging lithium battery, battery, and also it boosts the initial 3.7 volts to 5 volts in order to feed an Arduino Uno, connect at the same time to a real-time clock module for take into account the date and the hour of the measurements, and to the HT11 indoor and outdoor, and finally a module to save the data in a micro SD module. this part was installed, the HD11 were installed inside the birdhouse. And well, the other two models were with the Arduino were protected in a different box. And finally, also the solar cell was outdoors, obviously, but the battery was kept inside the same box of the electronics. Then we fabricated a homemade PCB data logger shield for this Arduino in order to compact all our circuit and only connect the modules separately, but not the micro SD module, because it's already welded to the homemade PCB. We installed then all this in this shield in the Arduino board, and then put it inside a box in order to take the measurements of these two DHT11. We closed all, and we prepare a nicely setup for outdoors. Okay, some pictures about the initial insulation results. And now a small video of how we were capturing the data. The data were timestamped in a TXT file, and then we process it in order to measure the delta T that we obtained. And we have observed that during sunset and night there was not big temperature difference in and out. Namely, it was not insulating anything, this kind of house. And during the day it was actually colder inside the house than outside. So in conclusion, it has a poor initial thermal insulation. Therefore we need to make some efforts, sadly. Okay, let the electoral customization and let the fun begins. Okay, for the electoral customization, we want to make the temperature keep resistant, or to maintain a temperature stable for a range of which the birds can survive. It has to be self-powered. It requires a controllable heating source. We need to control this heating system. It has to be compact also because of the size of the bird box initially. The most energy low consumption it can be. And well, we start by measuring temperature with an NTC. We combine also for the self-power solar cells 5 volts, 2 watts, 2 panels. For the heating system, we use as a heating source a ceramic heater of 5 volts, 8 watts, because of the size, which was 40 square millimeters. It has to be compact and the most energy low consumption, because it can be fitted, in this case it was at 9 volts, but we tested with 5 volts and it was okay. And we obtain a linear curve about the quantity of current consumption that needs this ceramic heater in order to get an amount in average of 0.125 amperes per each 5 degrees of increase in temperature. Then once we have the original design, we scan it and we 3D CAD resketch it in order to make some modifications. We split our development in 3 modules. The first module is the self-recharging electronics, which is related with the previous one observed in the data logger. it involves the two solar panels, the batteries, and it's this part that we already have seen. Then, by changing our design, we take a look of the space that we have, and we design these small T-shape supports in order to install the solar panels. Once we have done this 3D printed parts, we install them, as we can see in the roof, and in the same roof we install both the battery charger with the DC-DC boost and the battery also. In this case, we can have everything that we need for two power lines separated. And finally, our enclosure, it's like this. We have here the T-shape supports, and we have here the two solar panels installed. Then, for the modules 2 and 3, for Bluetooth temperature monitor and heating system, we take some information about the previous data logger, and we observe that it's kind of messy to have a SD card outdoors. We better prefer to have a wireless communication with the sensing that it's being done. No? In order to make this, we want first to control the temperature. Once outdoors begins to decrease the temperature, we require like a heating source that it's gonna introduce a wave of heating in order to keep warm the nest. Once the temperature is increased, we will turn off the heating system and start to blow a flow of cold air. Taking into account the previous schematics and diagrams, this is the complete circuit for the HiluxNest. It involves a briefly modification of the data logger, but now only including one DHT11 because we are using the RTC inside the house, and we have substituted the SD module for the HC05 Bluetooth module in order to receive commands and display the measurements. And finally, we have in a different power line of battery the high consumption components, which are the ceramic, obviously, and the fan we connected better in the low power consumption because it's not so much the current that it consumes. Then this part we install it below the original design of the house, creating this 3D printed support, and this 3D printed support also for the ceramic. And we install it the 5 volts fan above the heating system in order to make this extraction of heating wave within the nest. For this, these are some pictures about the 3D printed parts and the previous installation that we have done inside the house, and a cool video of the heater controlled by Bluetooth. We're setting on the heater, the ceramic is turned on, it's controlled by a PWM, and it starts to increase fast. its temperature. As we saw in the graph before, it can reach up to 50 or 60 degrees. This is a picture of one example, 51.7 Celsius degrees. And finally, the control of the fan by Bluetooth. So we connect to the device, we set a command, and finally we send it, and the fan is on. It's a really silent fan because it's from Raspberry Pipes, which are really like discrete in sounds. And the final assembly, it was like this. Kind of messy, a lot of parts, a lot of components that include inside a small box, and the final assembly looks like this. Well, in one word for this project, what a wiring. I mean, it was really struggling to wire all of it. So for that, we have achieved a resketch done for the 3D design improvement that we have done for install the solar panels and the electronics. We have done a compact heating system. And we also use an RTC that controls the latency of measuring. And we have tested and implemented the distribution of the heating wave that it's generated by the ceramic. And that will be all.